In these problems, we are going to incorporate molarity into this mix of stoichiometry problems. So, for example, we may be given a concentration and volume of a particular reactant, and we're looking to react it to produce a precipitate, and we want to find out how many grams of that precipitate or product are made. So I'll go through a couple of these problems, and hopefully you'll get the hang of it. Our first question states, hydrogen sulfide is a foul-smelling compound that can be a component of polluted air. It reacts with lead-2 ions to give black lead-2 sulfide. If you have 50 milliliters of 3 molar hydrogen sulfide and add lead nitrate in excess, that means you have lots of it and all the H2S is going to react, how many grams of lead-2 sulfide can be formed? And we're given a balanced chemical equation. Now, here's something to keep in mind. We're going to start with what we're given, and we're given information about the hydrogen sulfide. We know its concentration and its volume. A key thing to keep in mind is when you multiply a volume times a concentration, you're going to get moles. Let me show you how. Notice here how I took this volume in milliliters and I converted it to liters. The reason I did that is because when I convert that by the molarity, which I wrote out as moles per liter, the unit of liters will cancel and I get to moles. So once again, a volume in liters times a molarity is going to get you moles. From here, we can go to the mole ratio. So we're given the H2S, we're looking for the PBS, looks like the mole ratio is 1:1. Here's the mole ratio written out. Once again, please write a unit and a formula next to every one of your numbers in the problem. From here, we want to look for the mass of lead-2 sulfide, so we'll need to look up the molar mass of lead-2 sulfide and use that in our last conversion factor. There it is. The molar mass is on the top, and I've canceled the unit of moles by putting 1 mole of PBS in the denominator. From here, we do the math, 0.050 times 3, and times 239.27 grams, and that gives us a final answer. The final answer is 36 grams of lead-2 sulfide. I'm limited to 2 significant digits because of this volume right here, and that's it. In this question, we're asked, in the photographic process, silver bromide is dissolved by adding sodium thiosulfate. If you want to dissolve 0.125 grams of silver bromide, how many milliliters of 0.0265 molar sodium thiosulfate should you add? So this is clearly a pre-digital age photographic process. We'll start the problem by writing down the information we know about silver bromide, its mass, and then we'll convert that to moles. To convert the silver bromide to moles, we'll look up the molar mass of silver bromide, put that in the denominator, and 1 mole of silver bromide in the numerator. Next, we'll need to look at the mole ratio between silver bromide and sodium thiosulfate, and that mole ratio is 1:2. So we'll use that in the next conversion. Here I have 1 mole of silver bromide in the denominator, so that unit cancels, and the compound I'm looking for goes in the numerator, 2 moles of sodium thiosulfate. Now, in specifics, we're looking for the volume of this sodium thiosulfate, and we're given its concentration. So keep in mind that this capital M means moles per liter. So I'm going to write down this number. I'm going to write down the molarity, but I'm going to flip it upside down so the moles are in the denominator, and that will cancel moles and get us to liters. So here you can see, again, I wrote the molarity. I chose not to write a capital M, but rather I wrote moles and liters. And again, I flip it upside down so that my moles will cancel and I end up with liters. Now the question is asking me to find milliliters. So I have a couple of options here. One thing I can do is just change this 1 liter to 1,000 milliliters, and then I'll have my answer in milliliters. Another thing I can do is just write my answer in liters and then quickly convert it to milliliters, like this. Here's the result of my calculation in liters, and then I simply took this decimal point and moved it over 3 times to convert my answer to milliliters. So either way works just fine. I think that's it. Let me know if you have any problems, and hopefully you'll be okay.